All right, let's dive right in. We're building a complete mastery blueprint today for tackling discriminant questions in your Cambridge Additional Math exam. In that exam hall, your pen is your most important tool. And the paper? That's where you've got to prove your logic. Whether you're sitting the 0580, 0606, or any of the 4000 series exams, the discriminant is one of those topics that just demands absolute precision. So today, we're going to look really closely at the conditions for fx equals 0. We'll figure out exactly when it has two real roots, two equal roots, or no real roots at all. We're marrying deep mathematical theory with hardcore exam strategy, so you can literally slice through these questions with total confidence, no hesitation.
It's a super frustrating trap, but today we're going to dissect exactly why it happens and, more importantly, how you can avoid it entirely. To picture this, let's look at two typical students we constantly see in examiner reports, Alex and Sam. Look at Alex, he completely overloads the page with raw math facts. Equations dumped everywhere, but absolutely no analytical structure linking them. Then you have Sam. Sam rushes through the algebra, gets the correct final number, yay, right? But no, he completely misses the command word requirements of the actual question. Ultimately, both of these guys lose the majority of the marks. Why? Well, because getting the right number at the end is only a tiny fraction of the battle. The examiners are actually testing your method, your logic, and your precision.
To make sure we cover both the core math and the methodology the examiners actually want to see, we'll follow this quick agenda. We'll look at the unseen exam trap, decode the discriminant, set up a systematic processing framework, go over some critical examiner warnings, and finally, lock in those maximum marks. Okay, moving to section 1, decoding the discriminant. Let's get our theoretical foundations absolutely rock solid. This table brilliantly lays out the three specific conditions for f of x equals 0. It literally gives you the core causal relationships at a single glance. If the curve crosses the x-axis twice, boom, we have two real roots. Mathematically, that happens when your discriminant, b squared minus 4ac, is greater than 0. If the curve just grazes or touches the x-axis at a single point, it has two equal roots, meaning b squared minus 4ac is exactly equal to 0. And finally, if the curve is just floating out there, above or below the axis, never actually crossing it, there are no real roots. In that case, b squared minus 4ac is less than 0. Memorizing this table is your absolute baseline. But remember Alex and Sam from earlier? They actually knew these formulas, and they still bombed the question. Because knowing the formula is just step 1. Figuring out how to apply it to a complex multi-step problem, that's where the real marks are hiding. Now, what's super interesting here is that the syllabus specifically highlights top-performing students. They always show this connected, conceptual understanding that they can transfer to totally unfamiliar contexts. Principal examiner reports actually point out that candidates who reference cross-topic connections score significantly higher. So what does that mean for you? It means seamlessly linking what you know about the discriminant to other topics, like coordinate geometry or simultaneous equations. You're not just memorizing isolated formulas anymore. You're basically learning a new language of logical reasoning. You're proving how a curve behaves when it interacts with a line without even needing to sketch the graph. All right, section 2, systematic processing framework. Now that the theory is locked in, let's shift gears to the technical methodology you need to grab those top-tier grades, specifically the method mark strategy. Here's the massive takeaway. Cambridge prioritizes your analytical depth. They award marks for the correct process. The method mark strategy is literally the practice of awarding points for demonstrating correct, systematic processing and clear working, regardless of the final numerical outcome. Let me say that again, because it's that important, regardless of the final numerical outcome. If you make some tiny arithmetic slip up on line 2, but your logical steps are completely correct for the rest of the page, the examiner will carry that error forward and actually give you method marks for your valid process. But if you just write down the final answer with 0 working, even if that answer is perfectly right, you might get absolutely nothing, especially on show that questions. If the working isn't there, it's a 0. You simply have to prove your logic.
So to absolutely guarantee those method marks, you need to stick to this strict 5-step sequence during your exam. Step 1, identify your key elements. Carefully pull out your A, B, and C values from the quadratic. Step 2, apply the relevant principles. Explicitly write down the discriminant condition, like b squared minus 4ac equals 0. Step 3, execute your analysis with crystal clear working. This is where your algebra has to be flawless and, honestly, nicely spaced out. Step 4, verify your results. Ask yourself, does this answer logically make sense? And step 5, present it all in an appropriate format using the right terminology. By spacing out your work, stating the conditions right off the bat, and following this exact sequence, your mark potential just skyrockets. The math itself doesn't change, but your strategy completely shifts the game.
Just look at this comparison. On the left, a rushed, unstructured approach, and on the right, strict structural conventions. Proper presentation isn't just about making things look pretty, it's a professional skill examiners are actively hunting for. That unstructured mess on the left, it's basically a chaotic brain dump. An examiner literally can't follow it, which means they can't give you method marks. But strict conventions, they rule. Proper headings, the correct terminology, clean formats, it is night and day. When you present your mathematical arguments like the right side, you're instantly telling the examiner, hey, I'm a top-tier candidate and I know exactly what I'm doing.
Moving into Section 3, Critical Examiner Warnings. Let's take some direct insights from the principal examiner reports and flip them into a strategic advantage for us. Based on those reports, here are the top 3 mistakes that constantly drain marks from really smart, capable candidates. Warning 1, answers are way too vague. Warning 2, students completely forget about format and presentation conventions. And warning 3, final answers aren't specific to the given context. Let's break that down. The discriminant values dictate actual physical intersection points on a graph. If you aren't crystal clear about that relationship, boom, you hit warning 1. Or say you accidentally write, the roots are greater than 0, when you meant the discriminant is greater than 0. That mixes up the terminology and directly violates warnings 2 and 3. Details matter, folks.
So how do top-scoring candidates dodge those traps? By actively demonstrating evaluative thinking. They question assumptions and back up their decisions with hard evidence. Higher-order assessment really demands that you evaluate alternatives and justify your answers. For example, when you calculate a value for k using the discriminant, you can't just stop there. You have to evaluate if both the positive and negative values actually make sense given the physical geometry of the problem. Your brain should immediately jump to that systematic process. State the condition, substitute the equations to build a new quadratic, and logically work down to a structured inequality. That kind of disciplined reasoning, that's your ticket to maximum marks. This quote right here is basically your insider edge. The examiners explicitly put out an alert that says students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Think of your working out as your ultimate insurance policy. We all know how it is in the heat of the exam. Your adrenaline is pumping, the clock is staring you down, and it is so incredibly easy to drop a negative sign or mess up a basic multiplication. If you just jot down the final number, that one tiny slip-up destroys your score for that question. But if you lay out your working clearly, line by agonizing line, you're demonstrating your analytical framework, and the examiner will reward you for that mathematical logic.
Okay, Section 4, Securing Maximum Marks. Let's pull all of this together into your ultimate exam mastery blueprint.
By blending these cognitive domains together, knowledge, application, and analysis, you're building an absolute fortress against those common exam pitfalls. Let's quickly run through the core takeaways. Number 1, memorize those 3 discriminant conditions for f of x equals 0 until you see them in your sleep. Number 2, always apply that 5-step systematic processing framework. Identify, apply, execute, verify, and present. Number 3, make clear working your absolute top priority to grab those life-saving method marks. And finally, number 4, always review your final answers against the specific context of the question. Ask yourself, does this math make sense in the real-world geometry of the problem? If you bring this level of discipline to every single past paper you practice, the actual exam is going to feel like a total breeze. So, I want you to evaluate your own practice strategy right now, before you tackle your next additional math past paper. Are you still just hunting for that final numerical answer, or are you truly ready to master the methodology? Next time you're staring down a blank sheet of paper, ask yourself this: is my logic bulletproof enough to guarantee every single method mark? Keep that in mind and you'll do great.